All right.
Is that recording?
Yeah.
Okay.
Okay, ladies and gentlemen. So, Graham, do me a favor and go ahead and start reading the definition, please.
On what paper?
4.7. The one that you passed out.
It's on the board.
All right, ladies and gentlemen, let's go ahead and listen up to Graham as he reads the definition.
Definition of a function.
Yes.
Alright, must pass through the vertical line test. Every element of the domain X is paired with exactly one element of the range Y.
Okay. So, do y'all remember the vertical line test?
Yeah.
The vertical line test says this. If I draw a straight vertical line, it has to pass by at most 1 point, right? So at most 1 point. Can it pass through 0? Yes, it can. Can it pass through 1? Yes, it can. Can it pass through 2? No, it can't.
How would it not pass at this point?
Like for example, if you have a graph like
a segment.
like this is the like this, right? If I do a vertical line right here, is it going to pass through this point?
Nope.
No, it's not going to pass through any points. So that's why at most 1 point. It can pass through 0. All right. So this passes the vertical line test, so this is a function. This is the function y is equal to the sine of x. How do I know it's the sine of x and not the cosine of x?
Cosine starts with the valley.
Cosine starts with a peak or valley, right? Positive cosine starts with a peak, so it would start off right here. Sine starts where?
In the middle.
Origin.
At the origin. That's what we call it. Now, if I wanted to take the inverse of this and I reflected it over y is equal to x, this is what I would get. Does this pass the vertical line test?
Yeah.
Are you sure?
Oh,
Does
yeah.
it touch at most one point?
No.
So this does not pass the vertical line test. This is y is equal to inverse sine of x, or you could say y is equal to arc sine of x. How did y'all learn it? Inverse sine or arc sine?
Inverse sine. That's how you learned it.
Inverse sine. Okay. Now, Adrian, go ahead and read the paragraph, please.
In order to create a function, we must limit the domain. If the domain is restricted to blank, then the inverse will also be a function. Highlight the restricted domain on the graph above. Graph of y equals negative x.
No. Inverse sine. We
Inverse
just
sine.
talked about this. Inverse sine.
Will be a function as long as it's this restricted domain. By restricting the domain, each trigonometric function we can create an inverse trigonometric function.
Okay. Now, basically, this is saying this. If we were to cut off basically the top of this, right here, and the bottom of it, right here, so that all that's left is this bit right here, does just what's in between these two lines pass the vertical line test?
Yes.
Yeah, right? Do you guys see how it doesn't repeat like after itself? It will pass the vertical line test if all I'm looking at is between these two lines. Right?
Yeah.
So, what I'm going to do is I'm going to basically cut the graph from here to here so that it will be able to pass my vertical line test. Does everybody see what I'm doing? So I'm going to cut it from negative pi over 2 to pi over 2. I'm going to restrict its domain between this and this. So once again, I have it down here in this little box. If I'm restricting its domain, it's going to be what? Negative pi over 2 to pi over 2. What is its range going to be, ladies and gentlemen? What's the highest it goes? What's the lowest it goes?
Range would be negative 1 and positive 1.
Negative 1, positive 1, with brackets. Okay, now if we're looking at the inverse sine, what do y'all think is going to be the domain and range of the inverse sine?
I can't even tell what that graph.
Well, whenever we have the inverse function of another function, its domain will become its range, and its range will become its domain. So they just flip. So what is the domain of this function going to be? We don't even have to look at the graph.
Negative 1, 1.
That's exactly right. And what is its range going to be?
Negative pi over 2 and pi over 2.
Okay, let's look at this then.
We think we're
I'm sorry, I was 319. So I think you said these were fast.
Okay. Now when we're looking at cosine, can we do negative pi over 2 to pi over 2 as well?
What?
Can we do negative pi over 2 to pi over 2 as well?
Yeah. No.
What would happen if I took the inverse of this? What would this look like? Wouldn't it look something like this? Right, if I did negative pi over 2 to pi over 2?
Yeah.
So why is that not possible? Does this pass the vertical line test?
Yeah. No.
It doesn't pass the vertical line test, right? This would be some sort of C that wouldn't pass the vertical line test,
oh no, that is
right? From here to here, it doesn't pass the horizontal line test, so its inverse will not pass the vertical line test. However, will it pass the vertical line test if I cut it off from here to here?
yes.
It will. So I'm going to restrict its domain from 0 to pi. What is going to be its range, Adrian? What's the highest it goes? What's the lowest it goes?
1, negative 1.
Yep. So negative 1, comma 1. Now, Sam, what is going to be the domain of the inverse of my cosine? Uh-huh. And what's going to be my range, Sam, again?
0 and 5.
0 to pi.
Bless you.
Bless you.
Thanks.
Now the big piece.
Yeah, that happens.
Now, do you all see the difference between these two? Check this out. This one is going in which direction?
It's going to the right.
Yeah, it looks like it's going to the right. This one's going?
Left.
Yeah. What about the origin? Which one crosses through the origin?
Anyway.
Actually, Graham, hold on. Which one of these crosses through the origin? Inverse sine or inverse cosine?
Inverse sine.
Inverse sine. So I need you guys to keep these in mind.
Wait.
Everybody ready? Okay. Now, if I wanted to cut a slice of tangent to basically do the same thing, from where to where do you guys think I would cut? Where would I restrict its domain?
Negative pi squared, or negative pi over 2 squared, and pi over 2.
Yeah. So negative pi over 2 to pi over 2. Now, what's the difference? What is at negative pi over 2 and pi over 2, Graham? What does it have there? What are those dotted lines?
An asymptote.
So if it's an asymptote, does it ever touch?
No.
Nope.
So are we gonna use brackets or parentheses?
Parentheses.
There you go. What's its range gonna be? Brittany, what's the highest it goes? What's the lowest it goes?
What?
You're at the wrong spot.
Range. What's the highest that it goes? What's the lowest that it goes?
And negative infinity and positive.
Negative infinity and positive infinity. So what is going to be the domain and range of my inverse tangent function?
What?
Adrian, what do you think? What is going to be the domain of my inverse tangent function?
Infinity. Oh wait. Infinity and negative.
But how do you say it? Say it correctly in the correct order.
Negative infinity over infinity.
Not over, but just negative infinity to positive infinity. Graham, what's going to be my range?
Negative pi over 2, pi over 2.
With bracket or parentheses?
Bracket. Parentheses.
We're going to use parentheses because these are still asymptotes. These are horizontal asymptotes.
Oh yeah.
All right. Now, what's the whole point of this? The point of this is this.
Hold on.
Sarah, go ahead and read this, please.
When evaluating an inverse trigonometric function such as the arcsine, remember that the arcsine of x is the angle whose sine is x. You are determining the angle. Also, you are only to give answers on the restricted ranges for each inverse trigonometric function. List these ranges below. Memorize these ranges.
Okay, so the ranges for the inverse functions, we already know them. We did them on the page before. Negative pi over 2 over 2 to pi over 2. For inverse cosine, it's going to be 0 to pi. For tangent, it's going to be negative pi over 2 to pi over 2. Guys, please make sure you copy this down. Now, this, ladies and gentlemen, is where our unit circle is going to come in handy. Take a look at this. If I told you that if I told you on this unit circle to find negative pi over 2, where would you go? Well, where's pi over 2?
Power here.
90 degrees right here. All right, awesome. That's positive pi over 2. If I start at 0 and I go negative pi over 2, where would I end up? This is 90 degrees in the positive direction. Going pi over 2 or negative 90 degrees in the opposite direction, where would I end up?
3 pi squared.
3
pi over 2.
3 pi over 2. Do y'all see that? So basically this is saying from negative pi over 2 to pi over 2, this is going to be my range. So anything that I find, I'm going to find right in here. So this is going to be either in quadrant 1, quadrant 1, and quadrant 4. Now, from 0 to pi, Brittany, where would I find 0 to pi? What quadrants? If I'm starting at 0 and I go all the way to pi, which is over here, what quadrants would I be using?
Oh yeah, because it goes 1, 2, 3, 4. Yeah, 1 and 2.
1 and 2. So this is going to be quadrant 1 and 2. Now, what about for tangent?
Where we starting?
Well, this says negative pi over 2 to positive pi over 2. Adrian, what is it going to be?
Oh, it's up there. I didn't see it.
Where's pi over 2?
90.
Yeah, so where's negative pi over 2?
Wait. I mean, it should be in the opposite.
Yeah. So not quite opposite. It's not always going to be opposite, right? In this case it is. But basically if I'm here and I go pi over 2,
So just one.
this will be here. And if I go negative pi over 2, I'm going to go all the way over here. Do you see that? So it's just also going to be quadrant 1 and quadrant 4.
When do we ever use quadrant 3?
For now, we don't worry about it. Okay. So, what's the whole point of this? If I am looking at this first question right here, do you guys see how this says the inverse sine of negative 1/2? This says that the inverse sine of 1/2, negative 1/2, is equal to some angle. So this is going to be some angle. Now, basically that says that the sine of some angle is equal to negative 1/2. Now, sine is x or y? Sine is y. So where on here, ladies and gentlemen, between pi over 2 and negative pi over 2, do I have a y of negative 1/2? Do y'all see a y of negative 1/2?
Y of negative 1/2. Yeah. 11 pi over 6.
11 pi over 6. Okay. Now, is 11 pi over 6, is that number between negative pi over 2 and pi over 2? Think about it this way. If I turn this into 6's, this would be negative 3 pi over 2 and positive 3 pi over 2. Where is 11, sorry, over 6? Isn't 11 pi over 6 all the way over here?
Yeah.
So is it between these two?
No.
How can I denote this value between these two? Like, how would I put it between these two? Think about it this way. Okay. Think about it this way. 11 pi over 6 is basically starting here and going one full almost turn around, right? All the way over here. What if I start here and I go this way instead? How much did I go?
30.
I went 30 degrees in the negative direction. Do y'all see that?
Yeah.
So what? How can I say negative 30 degrees in radians?
Negative, well, 11 pi over 6.
Negative 11 pi over 6 is actually going all the way over here.
Oh, negative pi over 6.
Negative pi over 6. Do you guys see that? Adrian, do you see that? So this is actually going to be negative pi over 6. Does this fall between these two numbers?
X, yeah, it does.
So this is going to be your answer, negative pi over 6. Let's try this one right here. Arc sine or inverse sine of square root of 2 over 2. Which one of these has an arc sine, a y of square root of 2 over 2?
Pi over 4.
Pi over 4. Is pi over 4 between negative pi over 2 and positive pi over 2?
Yeah.
It is. So this we just leave by itself, pi over 4. What about this one? Inverse sine of 2. Where do you see a 2 for your y? You don't see it anywhere. So that means it does not exist. It's undefined. Because this is not in the range. That's all you have to do for the rest of these. Let me know if you guys have questions.